Hello everyone, welcome to another video. And in the previous another video, I discussed about questions regarding electromagnetic induction. Okay, so here I will be discussing questions on alternating current. Okay, I'll be discussing some good questions from it that may come in your board exam. Okay, so just write down first question. First question, write down the current in a discharging LR circuit. The current in a discharging LR circuit okay, discharging LR circuit is given by I is equal to I naught I is equal to I naught e to the power minus t by tau. Okay, where tau is the where tau is the time constant of the circuit. Time constant of the circuit. Alright. Calculate the RMS current for the period. Calculate the RMS current for the period t is equal to 0 to t is equal to tau second. The current in a discharging LR circuit is given by I is equal to I naught e to the power minus t by tau, where tau is the time constant of the circuit. Calculate the RMS current for the period t is equal to 0 to t is equal to tau. Try this question first. See, here I is equal to what? I naught e to the power minus t by tau, right? So if you see RMS current, we have to find out. RMS current means root mean square, right? So first of all, let's calculate the mean square. That is like this. Okay, so I square mean, right? I square mean. So I square mean will be 1 by tau, 0 to tau, okay? I naught square, the square of it, dt, e to the minus 2t by tau, dt. Okay, how I did it? See, I square mean is integration 0 to t, I square dt divided by integration 0 to t dt. Here t means tau, so integration 0 to tau, I square is I naught square e to the minus 2t by tau dt whole divided by 0 to tau dt. Okay, so if I write it, I square will come out I naught square 0 to tau e to the power minus 2t by tau dt whole divided by this is tau, right? Is that right? So I can write it as I naught square by tau integration of it this 2t by tau whole divided by minus 2 by tau 0 to tau. Okay, so I naught square by tau minus 2 tau by tau minus 2 by tau minus e to the power 0 is 1 by minus plus 2 by tau. Otherwise, we can do one thing. Let's take this minus 2 by tau out because it's too confusing otherwise. So take this out, I naught square by tau into minus tau by 2 because it comes out, right? E to the minus 2 tau by tau minus e to the power 0. So that gives me minus I naught square by 2. This is e to the minus 2 minus 1. Okay. So minus I naught square by 2, 1 by e square minus 1. I can write it as I can take the minus inside I naught square by 2, 1 minus 1 by e square. Is that correct? Okay. Now what is the, this is what we calculated. I square mean. Okay, I square mean root we need to calculate. We need root mean square. This is only mean square we calculated. This is only mean square. So root mean square means just the root over of this. Okay, so take the root over of I naught square by 2, 1 minus 1 by e square. Okay, so that will be I naught by root 2, root over of 1 by 1, sorry, 1 minus 1 by e square. This is your IRMS. Is that alright? IRMS is equal to I naught by root 2, root over of 1 minus 1 by e square. Okay, this is IRMS value. Okay, yeah, okay. This question is done. Now, question number 2. Question number 2 is okay, a register of resistance. A register of resistance 100 ohm is connected to an AC source. E is equal to 12 volt sine 250 pi second inverse t. Okay. Find the energy. Find the energy dissipated as heat energy. Okay. During t is equal to 0 to t is equal to 1 millisecond. A resistor of resistance 100 ohm is connected to an AC source. E is equal to 12 volt sine 250 pi second inverse t. Find the energy dissipated at heat energy during t is equal to 0 to t is equal to 1 second. Try this question. Your EMF is given. How to get the heat? Heat we know is how much? V square by RT. Okay. As R and V are given here, so we use this formula. Otherwise, we would have used also I square RT. But when I and R is given for that one, here it is H is equal to V square by RT, and your EMF is given 12. Your peak value of EMF is given E naught is equal to 12 volt, right? 250 pi. That means omega is given 250 pi. R is given 100 ohm. So it V square by RT. Okay, that is the formula, but we just cannot put it directly. Okay, we have to do some calculations. That is because this is EMF is varying with sine function, so we cannot just put the values because we have to take the integration. So H is equal to what? H is equal to 0 to H dH, and what is dH? Hmm? That will be see V square by R. Okay, dH is V square by R dt. Alright. So if we see, if we put the value V square, that will be E naught square sine square omega t by R into dt. And this is 0 to t, time t. And forget the limit now, for now. Just put these values. So E naught square by R Integration sine square omega t dt. Now we have done this integration so many times. E naught square by r. Integration 1 minus cos 2 omega t by 2 dt. E naught square by r. Integration 1 by 2. Let's take the 2 out. T minus sine 2 omega t by 2 omega. Alright, is that right? Hmm. Now what should you do? 0 to t. What is the time you are given? T 0 to t 1 millisecond. So put it 0 to 1 millisecond. 1 millisecond you have to put 10 to the minus 3 seconds. Okay. So E naught is how much? 12. So 12 square by 2 into R. R is 100 divided by, this will be your 10 to the minus 3 minus sine 2 omega. Omega is how much again? Omega is 250 pi into 250 pi into t 10 to the minus 3 divided by 2 into 250 pi. Yeah. So if you see 2 into 250 is 500. 500 into 10 to the power minus 3. How much? See. This is 0. 0.5. 0.5 is how much actually? 1 by 2. 1 by 2 and there is a pi. So it will be sine pi by 2. Got it? See. The question will be given in such a way you will be able to solve it. Pi by 2. Got it? This is 500 into 10 to the minus 0.5. 0.5 is 1 by 2. Sine pi by 2 divided by this is a 500 pi. Yeah. Sine pi by 2 is 1. This is 144 by 200. To the minus 3 minus 1 by 500. Just calculate this, you will get the answer. Okay. That will be a heat. The answer is 2.6 to the minus 4. Okay. Is it clear? Okay. This was a question number 2. Question number 3 right now. Capacitor or capacitance. Capacitance 100 microfarad and a coil of resistance 50 ohm and an inductor of inductance 0.5 Henry are connected in series with a 110 volt 50 hertz AC source. Find the RMS value of the current. Find the RMS value of the current. Find the RMS value of the current. Okay, try this question. Capacitor of capacitance 100 microfarad, coil of resistance 50 ohm, and inductor of inductance 0.5 Henry are connected in series with a 100 volt 50 hertz AC source. Find the RMS value of the current. Try this question. C is given 100 microfarad. If this is how much? This is what F is given 50 hertz. So omega is 2 pi F. So you can calculate XC is equal to 1 by omega C, right? 2 pi into 50 C, 100 into 10 to the minus 6. Done. Now, what is also given? Inductance is given. L is given. L is given 0.5 Henry. Frequency again is 50 Hz. Omega is 2 pi F. XL is equal to omega L. That is 50 into 2 pi into L is 0.5. 0.5 is actually 1 by 2. So this is 2050 pi. Okay. And RMS value of the current. Okay. See, RMS value of current is IRMS is equal to ERMS divided by Z impedance. Okay. What is the impedance here? Resistance is 50. This XLXC are there. Impedance is, we know formula of impedance, R square plus XL minus XC whole square. This is the difference sign. So you just put all the values, you will get the answer. Okay, very easy question. Nothing much is there in this. Okay, whatever you get, you just okay. When there is given in a this AC source, that means the thing that is given that is actually ERMS. When it is written like this, 220 volt, 100 hertz, 100 hertz, something like that. So this one is actually your ERMS. Okay, this is nothing but ERMS. This is not your E naught or anything. ERMS. So ERMS is already given. That is 110 divided by Z. You got Z here. Whatever you got. So just okay. Is it correct? Like, is it? Did you understand it? I hope understood. Right. Okay. Next question. Write down question number 4. The electric current in a circuit is given by I is equal to I naught T by tau for some time. Calculate the RMS current. Calculate the RMS current for the period T is equal to 0 to T is equal to tau. Electric current in a circuit is given by I is equal to I naught T by tau for some time. Calculate the RMS current for the period T is equal to 0 to T is equal to tau. Try this question. Okay, how to solve this? See, current is given. Okay, see, mean square current is how much? You are asked RMS current. First, as I said, mean square. No, 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 sorry. Mean square. Right. So again, 0 to tau I square dt is 0 to tau. So I naught square t square by tau square dt 0 to tau divided by tau. So I naught square by t, tau square goes out. T square dt is dq by 3 0 to tau divided by tau. Now I naught square by tau square into tau q by 3 divided by tau. See, this is tau, this is again cut. So I naught square by 3. Now what will be IRMS here then? IRMS we know is the root over of mean current, mean square, right? So root over of I naught square by 3, that is I naught by, is it correct? Is it correct? Did you get it? Just this is just the another like replication, like same kind of thing like this. Okay, and this is the formula for it. Hmm. Okay, there is an important question may come, like derive the expression for power in an AC circuit. Okay, power in an AC circuit. We should be able to do this. See, power, how to calculate? First of all, AC circuit is E is equal to E naught sine omega t. Okay, this is your EMF. So current will be what? Current is always there is some phase difference. I naught sine omega t plus phi. Omega t plus phi. Okay, sir. So your power is how much actually? Watt by time. Okay, watt by time. So, but here we have to find the power in an AC circuit. So for that we have to first find out work. So what dW is equal to what? EIdt. How? Because we know power is equal to what? Potential into current. So W is equal to PT from here. So VIT and dW is what? dW is VIdt and V is actually EMF. So E. Now put the value of E and I. E naught sine omega t into I naught sine omega t plus phi dt. Yeah, this is the expression. So if you take it out, this is dW. So E naught I naught sine omega t into sine omega t plus phi is how much? Sine omega t cos phi plus cos omega t sine phi then dt. Now what we have to do to get the total work done? We have to integrate it. Total work done dW 0 to W is equal to E naught I naught 0 to how much? 0 to t suppose. Total time is t. Sine omega t, let's multiply this. Sine square omega t cos phi plus sine omega t cos omega t sine phi dt. Okay. So E naught I naught goes out. Yeah. 0 to t sine square omega t cos phi dt plus 0 to t sine omega t cos omega t sine phi dt. Okay. See here dt is the variable, so cos phi should go out. So E naught I naught cos phi 0 to t sin square omega t dt plus sin phi will come out sin phi 0 to t sin omega t cos omega t dt. Now see integration of sin square omega t again E naught I naught cos phi integration of sine square will be 1 minus cos 2 omega t by 2 dt plus sine phi. Here I will multiply 2 and divide 2 because sine omega t sine theta and 2 sine theta cos theta is sine 2 theta. So 2 sine omega t cos omega t dt E naught I naught cos phi 2 goes out. This will be how much if I give this bracket t minus sine 2 omega t by 2 omega 0 to t plus sine phi by 2. This one is 0 to t integration sine 2 omega t dt. Okay. E naught I naught cos phi by 2. Put the values of t here. T minus sine 2 omega capital T by 2 omega 0 is 0 plus sine phi by 2. This integration is minus cos. Integration of sine is minus cos. Okay. 0 to t. Okay. So now there is E naught I naught cos phi by 2. See, one thing we know t is equal to 2 pi by omega. Okay, just so put it only here put it sine 2 omega into 2 pi by omega all divided by 2 omega. The minus will come out actually minus sine phi by 2 um, cos 2 omega t by 2 omega minus cos 0 is 1. Okay, by 2 omega. So here E naught I naught cos phi by 2. See, this is omega may cancel sine 4 pi. Sine 4 pi is 0. So into t minus sine phi by 2. Here see again cos 2 omega t is 4 pi. So cos 4 pi by 2 omega minus 1 by 2 omega. Cos 4 pi is again what? Cos 4 pi is 1. How? Because cos 0 is 1. And your 0 again another cycle 2 pi, another one 4 pi. These are all same. So cos 2 pi is 1. 4 pi. So this is actually 1. So 1 minus 2 omega, 1 minus 2 omega cancel out. This term whole again becomes 0. So the what is left E naught I naught cos phi by 2 into t. Okay. Can you tell me E naught I naught by 2? Can I write like this? E naught by root 2 into I naught by root 2. So I will just write it here E naught by root 2 into I naught by root 2 cos phi into t. So that will be what? E naught by root 2 is ERMS. This is IRMS. This is T cos phi. This is a what? This is only your work now. W. We were calculating W in the left side now. Yeah, W. What is power then? Power is how much? Power is W by time. So ERMS, IRMS, T cos phi by that is ERMS, IRMS cos phi. Is that alright? This is your power. Average power, we can also say average power. Is it alright? Hmm, I hope you understood. another question. Question 4, 5, 6. Question number 6. Transformer has 50 turns in the primary and 100 in the secondary. If the primary is connected, the primary is prim- check. The primary is connected to a 220 volt DC supply. What will be the voltage across the secondary? What will be the voltage across the secondary? Transformer has 50 turns in the primary coil, 100 in the secondary. The primary is connected to a 220 volt DC supply. What will be the voltage across the secondary? Try this question. Right to the A side. No, sorry, yes, no, right. See, how to solve this question. See, if you read this question carefully, 50 turns in the primary is 100 in the secondary. If the primary is connected to a 220 volt DC supply, what will be the current voltage across the to 220 volt? This is your what? DC supply here. But we know transformer works on the principle of what? Hmm? Works like electromagnetic induction. And electromagnetic induction is only possible in case of what? Alternating current. Okay, only alternating current. So for direct current it doesn't work. For direct current doesn't work. So for direct current, what? It won't work. So your voltage will be what? Trading current. So your what? Secondary voltage in the secondary will be zero. Simple. Is it alright? Because this is a DC supply, so your transformer won't like it won't work. The work won't work. Is it alright? So these are the varieties varieties of questions that may come from this alternating current. Okay, not much variety is there, and other derivations you should be able to do, hmm, like RMS current, all those things. Okay, anyway, I will do it. So let's derive RMS current and your average current. Okay, one question can come. Uh, One question can come. Yeah, this one. Average current. So you can question may come like question is 6 or 7, whatever. Average current over a period of average current of AC over a cycle is zero. Prove it. Prove it. Okay. Try. Try. I will solve it otherwise. Average current of AC over a cycle is zero. Prove it. Okay. Average current of AC over a cycle is zero. How to prove it? See, your instantaneous current is proof. Your instantaneous current is how much? I naught sine omega t. Sine omega t plus phi, right? Now, again, average means like this I bar that will be 0 to t I dt divided by integration dt 0 to t. Alright, 0 to t capital because this is for a complete cycle. This is I naught sine omega t plus phi dt 0 to t divided by dt integration is t. Okay. Now I naught goes out divided by t 0 to t sine omega t plus phi dt. Okay. Now integration of sine omega t plus phi is how much? Cos minus cos omega t plus phi whole divided by omega 0 to t. Okay, now put the value of 0, like t minus, take it out, omega also take it out. So cos omega t plus phi minus cos 0 plus phi, that is cos phi. Okay, now see, we know omega is how much, sorry, 2 pi, t is how much, t is 2 pi by omega. So put it here. So minus I not by omega t cos omega into 2 pi by omega plus phi minus cos phi d. Okay. So minus I naught by omega t. Omega omega cancelled out. So cos 2 pi plus phi. Cos 2 pi plus phi is how much? Cos 360 plus theta. That will always be cos theta. Okay. Why? 360 is here, 0, 360 theta. That will be theta will be in the first axis, right? First quadrant. So cos phi minus cos phi. That will be 0, right? So this is 0. This, so I average is 0. Got it? I average is your 0. Is that all right? Okay. Now this is one question done. Now is I approve IRMS is equal to prove IRMS is equal to what? I naught by root 2. This one you try first. Otherwise I will solve it anyway. First you try. Okay, how to do it? See, I average how I calculated 0 to t I dt divided by it is I RMS means I mean square, I square mean root over. So first I square mean will be what? Just the square of it, I square dt. Yeah. Now mean of I square, that will be root over of all this whole thing. Okay. Okay, let's calculate. So I square mean is equal to division 0 to t I square dt divided by 0 to t dt. I naught square sine square omega t plus phi dt 0 to t divided by 60. Yeah. So I naught square divided by capital T 0 to t sine square omega t plus phi. Okay, I naught square by t is 0 to t 1 minus cos 2 omega t plus phi all divided by 2. So I naught square by 2t. This is your integration t minus sine 2 omega t plus phi divided by 2 omega 0 to. Okay. So I naught square by 2t t minus sine 2, sorry, sine 2 omega t plus phi all divided by 2 omega 0 is 0. Yeah. Now, okay, 9, 9, no, sorry, minus 0. Here in place of 0, if I put, I will get sine 2 phi. Sine 2 phi by 2 omega. Okay. Yeah. right? So if I do this, t minus, see, 2 omega t means omega into pi by omega, that means 2 pi sine 2 into 2 pi, 4 pi plus 2 pi, okay, by 2 omega plus sine 2 pi by omega. If you see, sine 4 pi plus theta will be what? Sine theta only, right? We just did I naught square by 2t, t minus sine 2 phi by 2 omega plus sine 2 phi by 2 omega. So if you see, these two are cancelled. Now I naught square by 2t into t, which is a what? I naught square by 2. This is what only? I square mean. This is just mean square only. So root mean square means what? Root mean square means root over of this one. So root over of I naught square by 2. That is I naught by 2. So IRMS is I naught by 2. Okay. Yeah. Write a question. Question number 80 plus question number 9. Easy question. The peak value of an alternating current is 5 ampere and its frequency is 60 hertz. Find the RMS value. Find its RMS value. How long will the current? How long will the current take to reach the peak value starting from zero? The peak value of an AC is 5 ampere. Its frequency is 60 hertz. Find its RMS value. How long will the current take to reach the peak value starting from zero? How long will it take to reach the peak value starting from zero? Peak value of an AC is given as 5 ampere. Peak value I naught is equal to 5 ampere. Frequency is given F is equal to 60 hertz. RMS, find its RMS value. IRMS is asked. We know IRMS is how much? We just calculated IRMS is I naught by root 2. So 5 by root 2. Okay. And how long will the current take to reach the peak value starting from zero? Think that one a bit. To reach the peak value, how long will it take to reach the peak value starting from zero? Peak value. This is a current. Where is the peak value? This one is the peak value. Okay. What is the total time it takes to reach from zero to this is 2 pi? Total time is t. Yeah. Okay. Half. This is half. This is pi. So how much time does it take to reach from here to here? T by 2. So half time is t by 2. Okay, peak is what? Peak is the half of this half. Isn't this? If this is the half, pi is the half, peak is the what? Pi by 2. Half of half, that means half of t by 2. So this is your t by 4. So it takes t by 4 time to reach the what? Half value. The peak value. Okay, so we need to calculate t. T is how much? Okay, frequency is given 60 hertz. So t is equal to 1 by frequency, 1 by 60. Now, time taken to reach the peak value will be how much? T is equal to t by 4, isn't it? T by 4. T by 4 is 1 by 60 whole divided by 4. So 1 by 240. Okay, 1 by 240 seconds. If we calculate it, 1000 into 10 to the minus 3 divided by 240. So 100 by 24. It's like 12 by 50 by 12 or 25 by 6. So 25 by 6 is 6 fours are 24, 1 0, so 1 6 4 0 6. So 4.16, that means 4.16 into 10 to the minus 3 seconds. So yeah, 0, whatever, this is 4.16 millisecond we can write. Okay, this is the time it takes to reach the peak value of current. Is that all right? Do you know what is resonant frequency? Resonant frequency. What is resonant frequency? Like at the time when your capacitive reactance or inductive reactance is equal to capacitive reactance. Okay, that means XL is equal to XC, that is omega L is equal to 1 by omega C, omega square is equal to 1 by LC. Okay, that means omega is equal to 1 by root over of LC. So 2 pi F is equal to 1 by root over of LC. So F is your what? Okay. F is your what? F is your 1 by 2 pi root over of LC. And this F is your what called resonant frequency. Okay. This is called resonant frequency. Okay. Okay. It happens today. I hope you understood. I hope you understood everything. Is completely revised this chapter. So I hope you understood, and let me know in the comments if you have any doubts. Right? Yeah. Thank you very much for watching.